So when I teach, I tend to use a very loud voice. In the classroom, especially with masks on, you want to use a very loud voice so everyone can understand you. But for recording videos, you don't really have to scream everything. But somehow, I do tend to just scream everything. But what if we had a nice, relaxing video without me screaming? That's this one. Evaluating inverse trig functions. Exactly. That's kind of weird, actually. We'll try to do a happy medium, all right? So we're going to use the special triangles here, okay? So remember these special triangles that we have? One of the special triangles was pi over 6, pi over 3. They're both right triangles. And then the short side, the hypotenuse is always double the short side. And the long side of the triangle is the short side times the square root of 3. We had the other one as well, 45, 45, 90 triangle, or pi over 4, right? And in this one, the hypotenuse was square root of 2 times s. So these these special triangles rather, are going to be really useful for us in evaluating inverse trig functions exactly, as well as this little table from the last video, okay? We have to know what the range of our trig functions are because there's infinitely many angles that have a given ratio, okay? So let's kind of start with that. Look at special triangles. Look at positive and negative. Remember, all squids train camels. Always save the cats. That was another good one I got. All right, and then always look at the ranges of the inverse trig as well. These are the kind of the three things that we're going to have to look at when solving these sorts of problems. All right, so let's just jump right into it. Maybe not have a 20-minute video for once, and jump into example 2. Evaluate exactly. The calculator can approximate, but some calculators aren't very good at doing things exactly. They'll give decimal approximations, very good decimal approximations, but still decimal approximations. But if we want to evaluate exactly, we can also do this by hand. And again, I'm more than okay with you guys using computers. We all use computers for almost everything. Scientists use computers. Scientists are not really doing things by hand. But when you can do something by hand, it helps you understand. And that understanding lets you use computers more effectively. It lets you design computers. Anyone who's going into computer programming or something like that, being able to understand how things work is very important for being able to program it to work. Okay, so in this class, you can use a computer, but there's a lot of importance in also being able to do it by hand. You're never actually going to, almost never going to have to actually do something by hand, but it's an important skill for understanding and for cementing concepts, okay? So that's why I would implore, that's a good word, implore you to put some love into this video, all right? Part A. What is the inverse sine of 1/2? So remember, inverse sine takes in a ratio and spits out an angle. It's the opposite, it's the inverse of what sine does, okay? So what angle is going to give us a ratio of positive 1/2? Well, that's pi over 6, right? The sine of pi over 6 is 1/2. So pi over 6 is what we think of. Notice how I'm not writing it over here. That's because I'm not convinced that pi over 6 is our answer. We have to make sure that pi over 6 has the right sign. Pi over 6 is in the first quadrant, so it's positive. It should give a positive ratio. Good, we're getting a positive ratio. And we also have to verify that this is in the range of inverse sine. Is pi over 6 in the range of inverse sine? Pi over 6 is in this interval, yeah. Negative 90 degrees to positive 90 degrees. Good. So because we check those two things, we know pi over 6 is indeed our answer. So again, we're making sure that it's in the right quadrant. So it has the right SIGN sign, and it's in the range of arc sine or inverse sine. Okay, that's very, very important. You'll see why maybe later. All right, part B. Let's look at arc sine. Again, arc sine is the same as inverse sine of negative root 2 over 2. And hopefully by now you're getting more familiar with things, right? Negative root 2 over 2, that's the same as negative 1 over root 2. It's just one is simplified. It's a rationalized denominator, okay? But they're the same values. So what angle is going to give us this ratio? So my first thought is I see 1 over root 2. I think pi over 4. Because sine is opposite over hypotenuse. That's 1 over root 2. Okay, so I think pi over 4. But pi over 4 would give a positive ratio. Pi over 4 is in the first quadrant, would give a positive ratio. I need a negative ratio. So then I think, okay, maybe negative pi over 4. Sine's negative in the fourth quadrant. So maybe negative pi over 4. Let's make sure that's in the range of arc sine. Is negative pi over 4 in this range? Yes, it is. It is in this interval. The negative pi over 4 is good to go. All right, when I say evaluate exactly, different calculators do different things. So I just kind of want to show that off a little bit. If we do Desmos, for example, we do Desmos and we say, all right, Desmos, what is the arc sine of negative square root of 2 over 2? See, this gives me negative pi over 4, but it's in a decimal approximation. And again, you can also type in inverse sine. I don't know if you can do this actually. Yes, you can. You can type in inverse sine like this, or you can type in arc sine, and Desmos will take them both. We could also look at Google. What does Google do? If I say arc sine of negative square root of 2 divided by 2. So Google also gives you an approximate answer, negative pi over 4. And it gives you in radians, but you could specify if you want it in degrees. Again, make sure your calculator is in radians for this section. I don't think we're using any degrees until we get into some more triangle stuff later on in future chapters. Okay, so the exact answer is going to be done by hand. I think something like Wolfram Alpha or something would probably give you the exact answer. More complicated things, but basic calculators are just going to give approximations. All right, let's do a couple more. As a side note, that is how you would find a decimal approximation of all of these things. You could type it into your calculator. Let's do part C, cosine inverse of, I wrote it really small and it's kind of dark in my room, negative root 3 over 2. Oh, also my lighting setup's different, but it seems to be working. Inverse cosine of negative root 3 over 2. We have to go to our triangles. Cosine is adjacent over hypotenuse. How do we get this ratio? Root 3 over 2. Well, that's this over this, pi over 6. So think pi over 6 here. But the problem is, pi over 6 would give us a positive ratio. We want a negative ratio. How do we get a negative ratio? Well, these two quadrants don't work. These two quadrants give us a positive ratio for cosine. So it has to be in the second quadrant. We want a reference angle of pi over 6 in the second quadrant. Things are getting more complicated. We need the reference angle to be pi over 6. So what is this full angle? This full angle is going to be pi, or 180 degrees, minus the reference angle of pi over 6, or 5 pi over 6. All right, so this is the angle that gives us a negative ratio of negative root 3 over 2. And again, 5 pi over 6, that's not in this interval. That's more than pi over 2, but don't worry. We're looking at the range of arc cosine. The range of inverse cosine is the domain of cosine, and 5 pi over 6 is in this interval, so we're okay. And that should be our answer. And let's do part D as well. The arctangent, or inverse tangent, of positive 1. Let's consult our special triangles. What angle has the opposite over the adjacent tangent, right? Opposite over adjacent of 1? Pi over 4. So we think pi over 4, but does that give us the right sign? Yeah, pi over 4 would give us something positive. It's the first quadrant. And pi over 4 is in this interval, so we're good to go. Let's check our answers to all of these using a calculator. All right, calculators also give great decimal approximations as well. Right, so if the way that we check our answers with a calculator is, let's just type this in. Check C, right? Let's type this in to a calculator and see what our decimal approximation is. Arc cosine of negative root 3 over 2. Arc cosine of negative square root of 3, tab out of the square root, divided by 2. Gives a decimal approximation of 2.618. Is that 5 pi over 6? Good question. Let's find out. 5 pi over 6? Hey, look at it right there. It's also equal to 2.618 approximately. And you can do that with all of these, right? Inverse tangent of 1, arc tangent of 1. Let's see what that is. Arc tangent of 1 is about, is that pi over 4? I don't know. Let's see. Great. Okay. And remember to have your calculator in radians for this entire section. All right. I don't think there's anything in degrees in this section. And that's this video. That's how you get decimal approximations with your calculator. Calculators should have arc cosine or arc sine. You can also use Desmos or Google. Many options. All right, let me know if you have any questions or if you're running anything in particular. And I think this video was actually a little less yelly than normal. I think maybe? All right, good luck.